Hi all, welcome to the session CS22071 Agile Methodology presented by R. Samundi, Assistant Professor of Computer Science and Engineering. Today we will see Unit 2 Agile Process. In that Unit 2 we are going to see the topic as Lean Production. In next slide, so what is the in this session focus? So throughout this session we are going to learn about what is lean production, how does lean connect with agile and the theory of constraint, and why traditional software management fails, what is the core challenges and their impact. And next one is the introduction to throughput accounting as a superior financial lens. The three pillars of profitable software production: throughput, investment, operating expense, waste, its forms, cost, and how lean or agile reduce it. And next one is managing inventory, lead time, flow, and uncertainty with actionable lean agile strategies. Next, constraint in software like people, time, scope, budget, resource, and their management. The role of batch size, buffers, and aggregation in maximizing value and minimizing risk. And final, we will see what is a summary and a call to action, how you can apply these principles for real business impact. And next we will move into what is lean production principles in agile. For this, definition is lean production principle in agile focus on eliminating waste, optimizing workflow, and continuously improving to deliver customer value efficiently. By applying the theory of constraint within software development, Agile aims to make delivery process cheaper, faster, more reliable, and transparent. And next we will move into the economic imperative for software. Software industry in 2003 faced rising cost, poor result, quality issues, and lack of transparency. That is, by the early 2000s, software project had become expensive with low quality and little visibility. Business response include offshoring and lays off. In other words, companies tried outsourcing to reduce the expense, but it did not solve the deeper issues. To remain competitive, management technique and working practices must evolve. This shows that to stay competitive, new management practices were required for better result at lower cost. So software must deliver better, more reliable outcomes at reduced cost with increased transparency. So now we will move into next slide, that is current state of the software development. Here the IT viewed as cost center. This means executives often saw IT as an expense, not as a source of business value. Poor management increases cost and waste jobs. In practice, weak management lead to higher expenses and frequent failures. Executives struggle with spiraling cost and poor quality. In practice, weak management lead to higher expenses and frequent failure. The global communication is fuel offshoring. In other words, with easier communication, companies sent work abroad but quality problems remained. And next one is the traditional focus on accurate estimates and lead to heavyweight inefficient process. This explains why rigid process and heavy reliance on estimates slow down the development. And next we will move into the agile management, a new paradigm. Agile provides a powerful alternative drawing on lean and TOC principles. This means Agile draws from lean production and theory of constraints to provide better way. Agile is deeply rooted in lean production. It focuses on profitable, value-driven development, not just productivity. In simple terms, Agile measures success by the value delivered to customer, not just productivity. It demonstrates improved value added and ROI. That is, Agile projects show how better financial returns because they prioritize valuable works. Now we will see drawing from proven industries, that is manufacturing. Manufacturing 1980s to 1990s transformation brought large economic gains. This means lean methods brought big improvements in flexibility, efficiency and quality. Improvements included flexibility, reduce the inventory, lead time, better visibility. Agile could unlock a similar 95% of efficiency improvement in software production. This shows that Agile could achieve up to 95% efficiency improvement in software. Next, we'll see as lean production, a synthesis. Here combines theory of constraints, that is for bottleneck focus. This means we look for the slowest step in the process and improve it. And next one is just in time, that is used to reduce the inventory. It is for inventory minimization. In simple terms, we only work on what is needed when it is needed. And next one is TQM, total quality management, and Six Sigma, that is they reduce defect and variation so products remain consistent and reliable. And next slide we will see introducing the throughput accounting for software. The throughput accounting is a superior model for software management. This means success is measured by how much customer valued work is delivered, not just by cost. It focuses on maximizing the throughput customer valued work are delivered. Here the metrics are throughput, investment, operating expense. Here we are giving more importance to throughput. After that we are giving importance to investment. After that we are last finally we are give importance to operating expense. So next we will move into the goal of business making profit. Business core goal excluding non-profit is to make a profit. This means software development should create value that customers are willing to pay for. System Software system goal deliver profitable output, not just code. That is only features customers use and find valuable count as throughput. Delivered output is throughput only if customer values it. TA aligns. TA means throughput accounting aligns delivery with timing, budget and scope for meaningful progress. It ensures the project deliver meaningful result while staying on track. Next slide, we will see the three pillars of profitability and ROI. The three pillars is used for to maximize the profit and ROI. What are the three pillars? Is increase the throughput, decrease the investment, decrease the operating expense. These pillars provide a framework to understand Agile financial advantage. This means delivering more valuable software more frequently, that is increasing the throughput, and another one is that is decrease the investment means cut down the cost in requirement gathering, avoid unnecessary documentation. If it is decrease the operating expense is reduce effort on non-value work, avoid building unnecessary features. Now we will see in next slide as increasing throughput. Increasing throughput means the throughput is equal to actual cash generated via sales, not just output effort. If your software T equal to functionality deliver, that is client's value. Increase the T, that is throughput, by delivering more valuable software more frequently. Agile focus on maximizing client valued delivery. Next one is decreasing investment. Investment include money invested in the system plus idea generation, that is requirements. That both combination is decreasing investment. Requirements are assets as client valued ideas. Lower the investment by reducing requirements gathering cost via linear direct communication. The direct communication need less documentation, and decreasing the operating expense equal to money spent converting ideas into working code. In software, all works is operating expense, no work inherently value adding by itself. Labor is largest operating expense portion. Reduce the operating expense by building only truly valuable features. And next we will see the comparison between throughput accounting versus cost accounting. Here, what are the key difference between the throughput accounting and cost accounting? If it is a cost accounting, it will focus on operating expense. If it is a throughput accounting, it focus on delivered throughput. That is, it is focus on software. It is focus on labor. Cost accounting assumes local efficiency equal to global. If it is a throughput accounting, focus on holistic system efficiency. In cost accounting, it focuses on value added to unfinished work. If it is throughput accounting, the investment depreciated over time. Cost accounting, lead time not discouraged. In throughput accounting, minimize the lead time. Cost accounting often leads to poor decision. If it is a throughput accounting, it drives global optimization. And in next slide, we will see software development as a transformational system. Software transforms abstract ideas into executable code. It is a complex adaptive system with multiple feedbacks. So, based on the multiple customer feedback, it will adapt everything. Transformation stages, analysis, design, coding, testing, not solo phases. So, it will focus on all the phases. Next, it produces emergent artifacts and properties. And next, we will move into stages of transformation. Idea to working code. Idea flow through the system as a single phase flow. Multiple feedback loops allow correction and adaptation. All development methods transform ideas incrementally. Continuous flow is critical to delivering the value. The system goal in software development, the system goal is a desired behavior that can be, it is a profitable delivery of a software. Undesired behavior waste the energy. Eliminating waste reduces operating expense while sustaining throughput. Ultimately, the goal is profit, not mere code. Next, we will see the waste reduction, that is MUDA in software. Waste equal to energy spent that adds no client value. Agile actively seeks to reduce waste by embracing change, that is adapting the change, avoiding valueless products. Lower waste result in higher production rate. And next we will see the types of waste in software development. Typical wastes, abundant or stale requirements with zero value. Next one is excessive or duplicate documentations. Third one, building unwanted features. Fourth one, rework due to defect and miscommunication. And last, ideal inventory, that is waiting time. These are the type of waste. So waste cost may equal that of produced work. Next, we will see the optimizing flow of value. Steady, smooth flow of client value is key for maximizing utilization and efficiency. Flow disruption arise from bottlenecks, poor quality, large batch sizes. Here we use cumulative flow diagrams to monitor, improve the flow. Next we will see minimizing inventory, that is work in progress, that is WIP, and lead time. Inventory equal to ideas currently being processed or waiting. It reducing inventory lower the investment and operating expense. So lead time equal to time from idea inception to working code delivery. Short lead time reduce cost and risk for obsolescence. Little law relates inventory, throughput and lead time. The power of small batch sizes. Large batches cause poor flow, longer lead times and high inventory. Small batches enables improved flow, higher quality, reduced lead times or inventory. So behavior making batches too small where setup time outweighs processing efficiency. And next one is managing uncertainty with buffer. Software development is inherently uncertain. So we can't predict that. Agile manages uncertainty via buffers to protect constraints. Buffer can be people, time or resources depending on the constraint. Larger buffer are needed when uncertainty is higher. The less waste, the faster and cheaper delivery becomes. And next one, the 5 constraints of software development. Agile recognize and protect the 5 constraints, that is people, time, functionality, budget, resources. These are the 5 constraints of software development. People as a main constrained resource needs buffers for productivity. This means productivity depends largely on human skills and capability. And second one is time, that is schedule, delivery date, buffers. Deadlines should allow flexibility. And third one is functionality. Functionality managed with operational requirements. We can prioritize essential work while keeping other requirements. And fourth one is budget. This means spending is kept under control by not overloading the system. And last one is resources, tools, equipment with sufficient availability and buffers. Proper allocation prevent delays. Now we will move into next one is aggregation reduces uncertainty. Aggregating small tasks before buffering reduces total buffer size. Traditional methods add excessive local safety to each estimates. This means instead of every person adding extra time, we manage uncertainty at the system level. Next one is sequential task uncertainty. Sum of variances square root. That is, delays in one task cause more delays in other task also or overall progress also. And next one, parallel task uncertainty, maximum single uncertainty. In other words, uncertainty in parallel work is determined by the most difficult task. In next slide, we will see the overall summary and call to actions. Agile management is deeply rooted in lean production and throughput accounting. Here we are focus area as software as a transformational system. It emphasizes increasing throughput, decreasing investment and operating expense. Central importance of waste reduction. It optimizes flow, inventory and lead time. It uses small batches and buffers to handle uncertainty. Agile provides a framework for predictable, effective and profitable software development. Be an agent of change. Apply these insights to gain competitive advantage. This means it combines efficiency, quality, financial focus on doing more valuable work and less unnecessary work. Using with lean makes software delivery more predictable and efficient and profitable. So up to this, today's session is over. Thank you.